Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in Engineers in Progress, particularly on uniform motion problem. This problem is quite challenging and I hope that you can follow the explanation and the solutions, thereby enhancing your skills in analyzing mathematical problems that would be needed in your engineering preparations. But those who want to anticipate the solution, you can do so by pausing the video if you want to attempt to solve this problem. So here is the problem. A battleship started on a 500-mile voyage but was brought to full stop an hour after starting for military reasons, delaying it for full hour, after which it was ordered to proceed at a reduced speed equivalent to 75% of its former rate. The ship arrived at its destination 3 hours and 3/4 after scheduled time. If it was desired for the ship to arrive 1 hour and a quarter sooner, how far from the destination should the ship have been ordered stopped? So there are two situations in this problem, but when the ship was ordered to stop, the same condition applies. That is, it was delayed for 1 hour and the speed is reduced 75%. So we are given the idea that for the second situation, the ship should be ordered closer to the destination because it is mentioned here that the time is reduced by 1 and quarter or 1 hour and 15 minutes sooner. So that's than the preceding situation or condition. So to help analyze the situation, let's draw the figure. We have the starting point. Then take note that the ship has traveled 1 hour already, full stop air, and the distance would be speed, the normal speed times time 1 hour. And take note that for this position of the ship was delayed another full hour here before proceeding with a speed of 75% of the original. And the travel time is denoted by T sub 2. This is the destination and the expected time that the battleship should reach this destination is denoted by capital T. We will denote that by capital T. And the distance from the starting point to the destination is 500 miles. So therefore, this distance is 0.75 v, 0.75 of the previous speed times travel time t2. So we will denote the travel time t2. So the distance v times 1 plus this distance would be 0.75 v times t2, then equals 500 miles. So what is t2? So 1 hour travel time up to this position plus delayed 1 hour, 1 plus 1 plus t2, then equals, we equate that to the expected uh, time of arrival here, but it was mentioned that the ship was delayed, or the ship arrived at its destination 3 hours and 3/4, so that's 3.75 hours. So 1 hour plus 1 hour plus T2 equals 3 points, equals time of arrival, expected time of arrival plus 3.75. Simplifying T2 is capital T plus 3.75 minus 2. So that would be capital T plus 1.75. Substitute here. V plus 0.75 V times quantity T plus 1.75 equals 500. Then we can now set up the first equation. V, 1V plus 0.75 V times 1.75 combining, that's 37 over 16V plus 0.75 V times capital T equals 500. Call that equation 1. For the second situation, let's draw again the starting point. Let's have the starting point. The ship should travel for a time T1 with a speed of V, and this is the point where the battleship was ordered to have full stop, and the travel time here would be, we will denote T1, and travel time from this full stop to the destination as T3. So this is V times T1, the distance. We do not know T1, and this is T3. The distance would be 0.75 V times T3, speed times time, and the total distance would be 500 miles. So we are looking for this D here, and D is equal to 500 miles minus VT1. So T1 plus 1 hour delayed, then equals capital T plus T3 equals capital T plus 3.75 minus 1.25, where 1.25 is 1 hour and a quarter of an hour, or 1.25 hours. So this should be the time where the ship arrived, as mentioned here, arrived 1 hour and a quarter sooner. Of course, that is compared to the previous situation. So simplifying T3 is equal to 3.75 capital T minus T1. Then this is 2.5 minus 1, so 1.5. So T3 is capital T minus T1 plus 1.5. Then we substitute into this equation, equate to 500 V times T1 plus 0.75 V times quantity capital T minus T1 plus 1.5 equals 500. Then combining like terms, we have VT1 0.75 V times 1.5, then VT1 minus 0.75 V times negative T1, so that's 0.25 VT1. So 9 over 8 V plus 0.75 VT plus 0.25 VT1 equals 500. So in order to eliminate 0.75 VT from here, we subtract equation 2 from equation 1. So 37 over 16V minus 9 over 8V. That would be 19 over 16V, then minus 0.25 VT1, because this is the term in the left side that cannot be eliminated, then equals 0. So of course, we can cancel V or transpose this to the right. 0.25 is 1/4 also. So 19 over 16 equals T1 over 4. So from here, T1 is 19 over 16 times 4, and it is equal to 19 over 4 hours. Having found T1, then we set up that this D here, because the question is how far from the destination should the ship have been ordered stop. So this should be the distance D required, and it is equal to 500 minus VT1. Then of course we have to solve for V, the normal speed, so that the battleship will arrive at its destination without delay, is normal speed times capital T, that should be the travel time, equals 500 miles. So distance equals 500 minus VT1, that's the working equation. And and V times capital T equals 500. So we substitute this Vt into this equation 1 here to solve for V. So 37 over 16V plus 0.75 of 500 equals 500. So 500 minus 0.75 of 500 is 125. So 37 over 16V equals 125. So from here we can solve for the supposedly normal speed of the ship, battleship, which is equal to 2000 over 37 miles per hour. Having found this, we now substitute this into our working equation here. V is 2000 over 37 miles per hour and T1 is 19 over 4. So we can solve for D. D is 500 minus 2000 over 37 times 19 over 4. So D is equal to 243.243 miles. So that's it for this problem, and I hope that you were able to follow, understand the explanation, and the setting up of these equations.